get a confirmation. Yes, hello, we're also live on YouTube. So I would like to welcome everyone to our new show and tell, doing his work on robotics with the use of Pixi and other tools in the ecosystem that we're working on. Yeah, and I would like to give him the chair to show and tell his presentation.
Right. Thanks everyone. Thanks a lot for the invitation. Sharing the slide. So I prepared a few slides just to put in context what I do and what the people I work with do. And then I'll actually do a bit of show and tell of something that we're doing. So first of all, let's see me introduce myself. I'm Silvio Traversaro, an applied scientist at the Artificial Mechanical Intelligence Research Group at the Italian Institute of Technology. We do many things. Our main, let's say, point of interest, point of research is human robotics. I'm not going to in details of what we are doing. We do a bit of aerial human robotics that exist and humanoid robots that autonomously navigate the environment and interact with people. If you are curious, just go on our website. But what I think is important for this presentation is that we are a big group of people. This is just the group that I'm working on, and more or less 45, 50 people. Then we have other groups in IIT that we interact with, that we share code with, that we develop code with, we share robots with. So we have a huge historical, let's say, concern in making sure that our software can run easily on multiple platforms. Multiple platforms is important because we have mechanical engineers, electrical engineers, different people, different background. And something that I always show to people that need to work in research and work in software is that you need always to take in consideration there is an inherent trade-off in the software that you develop, because you can put constraints in development. Oh, sorry, okay, this was not expected. This was a task before. So there is always a constraint that you can put in development, such that, okay, more tools, more linting, more constraints, but and typically constraints ensure that your code is more robust, more reusable, more scalable. For example, I could force all people to use Pixi, and then automatically is much more reproducible. But then on the other hand, if you are working in research, the more, let's say, constraint you put to people, the less they are freedom to innovate. They may have workflows that they are used to, and if you impose them constraints. So I think research software is a bit different with, I don't know, with respect to, I don't know, a company that's developing an app and their product is clear. So there is always this kind of trade-off between super high constraints, but low flexibility or low freedom to innovate. And on the other hand, having a high freedom to innovate, but then having problem in reusing the software. For example, the classical, I don't know, person that works alone, does not use Git, just save the code in USB keys. And if you do research software, I think the key point is that you need to find a trade-off in the middle. That's not written in a manual. For each situation, the trade-off is different, but it's fundamental to understand that you need to put a bit of constraints such that you get all the benefits, but without the limiting the motivation. And you need to find some point in the middle. From this point of view, I think it's also important to realize that when you do research, there are always two kinds of software, two kinds of repos. You have software repos that you want to be able to easily reproduce because, for example, they reproduce the results in a given experiment, in a given paper. And on the other hand, you have library that you want to reuse across different papers, and you also want people outside of the lab to use for their experiment. And these two kinds of software have different constraints, different needs that is important to realize. In our lab, to achieve this, we try to have one repo for each paper that contains all the code that goes in the experiment for the paper. And you can find this if you go in our organization and search for all the repos that start with paper underscore. So I think those are paper-specific repos. All the other repos instead are generic software repos of reusable library. Try to keep this difference. And something that I want to, let's say, I would like to discuss during shows. I would like to show you how we use Pixi in some of these paper repos to enhance reusability in different scenarios, different stack, different cases. And something that plays a big role is that how these two of software are related. Those are paper specific repos and reusable libraries repos related. That is where a tool like pixi enters in the room, because typically in reproducible paper you want to be extremely specific in the kind of software that you use, down to the versions, to the exact version, because you want people to be able to reproduce what you are using. And to do that, you typically use log files. So you have your reproducible paper repo that does not contain all the code, because all the libraries are not contained in the repo, because that will be a maintenance nightmare. But you want to easily permit people to use exactly the same library that you use in your experiment. And this, you can do that with any tools that permits you to create easily log files. And in our scenario, pixi was the ideal candidate, let's say. So at this point, I would like to start. So in any case, if you have any question, any curiosity, feel free to interrupt me. But then, having said this theoretical introduction, I would like to go and give you a specific example, a real world example. These are real papers that have been published in the last let's say 2 years, of real experiments on real human platforms that have been published and been accepted. So they are not like examples that are all lean. They are also a bit ugly from some point of view, because they are the real example in real world. So the first example that I want to show you is of a paper that is being actually presented this weekend at the International Conference of Human Robotics, that is about the automatic gain of controllers for the walking of human robots. Without going too much in details, the basic idea is that if you have a controller, a model-based controller, but even if you are using machine learning, you always have hyperparameters. And you want to tune these hyperparameters. And fortunately, in the recent years, the amount of software tools available for doing, let's say, Bayesian tuning of these parameters exploded thanks to machine learning. And these papers let's say, applies these techniques to the gain tuning of the walking robots. And is a fairly, let's say, classical repo, because it just contains some Python scripts and installs some, Python dependencies. So this is the, and if you go down in the instructions, you can see that the pixi instructions are quite minimal. You just need to download a repo and run a task. And this will permit you to either optimize the gain, but that takes several hours, so I'm not going to do that, or to check the output of one optimization. That is what I'm going to show you today. So let's go really and to the example. So I'm on Windows also, because some of these papers have been developed in Linux, some other in Windows. So in Windows, I can use WSL2 to show them both to you. And okay, so first step, downloading the repo. Unrelated, show you. So if we go here, download the repo. I hope the font size is okay. I don't know if it's you prefer it a bigger, just tell me, don't worry. And then once I download it, okay, perfect. Wrong the paper. Okay, so I just downloaded it, and then I can run the instruction that we provide in the repo. And this is probably, I think everybody here is familiar with pixi, but basically this will automatically install all the dependencies and run the script. Clearly, there is a bit of warning, because that is a real paper. And this, you see, it's a simulation running in Bujoko of one run of the algorithm, not a particularly successful one. You can see that the robot is stepping in place. So the parameters were not really good on this kind of specific experiment. But what I want to showcase is that with one command, probably, I guess if you are here, you are sold on on pixi, but with one simple command, you can easily reproduce the experiment. So let's close it before we get to let's say bored by this. Something that I want to show is the actual pixi TOM file that we use in this case to show you a real case. It's quite simple. It's just a Linux paper, some scripts, some Python script in a folder, not even a Python package, a bunch of dependencies. Some arrive from conda, some are not particularly pinned, some other instead are pinned by the author because he was doing experiment and he want to make sure to use exactly those one. There are also some workarounds for specific issues related to ABI compatibility of Python bindings. That is a bit ugly. You don't see this in examples, but that is what you typically encounter when we develop, you write software for a paper. You have a deadline and you need to make it work. You cannot always fix the problem upstream. We put a lot of effort in fixing things upstream, but sometimes if you have a deadline, you just want to use exactly the version that is working for you. Then perhaps you forked some repos and you want to download them exactly for your from your fork because you did some modification that ideally you want to submit upstream, discuss the pull request, but that doesn't typically fit the schedule before a deadline of a paper. And so being able to easily tackle this information inside pixi is really helpful for us. So I don't know if anybody has any question related to this example of my presentation. Otherwise, I go to the second example. Okay, I guess it's okay with the second example. This is a bit different. I think this is a bit different from what most people, I guess, robotics community or also pixi community may be familiar with, because this is a paper from 2 years ago. It's really interesting about developing basically morphing covers, like a bit of transformers, because in the context of flying humanoids, you may want at some point to have a shape that changes over time. It's quite explorative work, but really interesting from, yeah, sorry?
No, sorry.
Sorry, my bad.
We're just saying like the flying is really cool.
Yes, I know. I try to skip over because that's not the point. Otherwise, people will for career. But really, you can go on the website, the videos, paper. It's. But the interesting thing is that the stack here is quite different because the main author is a mechanical engineer, so it works all the time in Windows. He's using for this specific paper MATLAB. That is not something that is easily, I don't know, installable, with some MATLAB bindings that are compiled from some C++ library and then some custom MATLAB libraries. And still in that case, we can again use pixi to automatize. Sorry, let's go in the repo. So this is on Windows, so I will use the command prompt. Let's go to my hard drive because it's a bit faster. Let's do it from scratch. Also, I can then show you the code. Okay, that's it. And then the instruction are that I need to. So this is the alternative because most people don't use MATLAB as an interpreter just by it. They open the GUI. But to showcase you, I think it's more familiar if I just run an experiment. So I just run an experiment. Folder that is available. This will install all the conda dependencies. Will not install MATLAB. That is actually something that you expect to have in the system. It's like a bit Visual Studio when you do C++ development. It's not something that conda or anyone is allowed to redistribute. But it will install all the conda dependencies, all the conda packages for the Python, for the MATLAB dependencies that are compiled. We don't keep them in the conda forge channel because they don't support, but one of our channels. And then it will install the pure MATLAB dependency developed by the author that is instead in a reusable repo. That is this Mystica one. So this is downloading all the conda environment, downloading the source repositories. Again, this, by the way, is something that will be really cool to do through pixi build once it's available, and then he start MATLAB. MATLAB, the startup time is not ideal, so I think I'll show you the pixi toml in the meanwhile. So this is probably a bit more complex for most of you. So it's something that is supported on Windows and Linux. Is the channels we have conda for, but also our own channel that is Robotology, because we need to somewhere to host MATLAB compiled binaries. And to do that, you need some tweaks in the CI that is not at least trivial to do in CondaForge. It will be possible, but it's just not the fastest way. And then this is the critical part. We need to modify the MATLAB path, that is kind of the equivalent of the Python path in MATLAB, to tell MATLAB where to look for libraries. Okay, by the way, something started. So the simulation was actually successful. Then it's going on. So you can see that is the integration start, and then there is also the result of the simulation. In this case, the mechanism is being controlled to reach the desired shape. And by the way, it's really cool work. Go to read the paper. But what I want is to stress out is that here, without basically having to anything, even with a stack that is not something that is super, let's say, used inside the core robotics community, you can make the paper reproducible. Something interesting is that while this is nice if you just want to run an experiment, people using MATLAB are more, let's say, used to actually run it as a GUI and run scripts from there. And through Pixi, you can do that as well. You just need to do pixi run MATLAB. So MATLAB will start with all the correct environmental variables. And then if you go here and start the script, it will have exactly the same result that you showed before. And by the way, there is actually a really cool script doing this kind of simulation on the leg of the humanoid robot. It just takes a bit too much time for this show and tell. But I think if you want to run it out and test it, the only problem here is with MATLAB, you need to have a MATLAB license. And if you are not in a university, probably that is a bit expensive. But still, it's something that I want to stress, is that you can have really complex examples that are also have quite a strange stack, and you can still reproduce them with Pixi. So at this point, I have a third example. I don't know how much time do we have got, if we want to do some question, or I can just start the third example, and in the meanwhile that it starts and unload dependencies, we can take questions. I don't know. That is, let's say, totally fine for me.
Please do another example. It's
okay.
really cool.
Okay, so for the
Never
third
thought about
example,
using MATLAB.
I was kind of stalling on this example because I think this is a really interesting example, because it showcased launching a huge number of let's say modules. So a bit, it's not using ROS underneath, but it's kind of the same concept. You don't just launch one script or one executable, but several executables. And also it tackles the problem that this paper actually require a non-redistributable library written in Fortran. So it's like the ultimate goal. I actually prepared it 2 days ago, because this is a paper that, again, has been presented this weekend at the International Conference on Human Robotics in Nancy. But let's try if it works. So actually, I already downloaded it, because it takes a bit of time to download it. So, and okay, sorry, I'm not really the smoothest presenter. Okay, so again, this
Fits
paper
the
is
research.
sorry?
It fits the research. Your all of this.
As you know, it's like So, so this is interesting, by the way, is the paper that is about integrating classical working algorithms with the stylistic style coming from a human through deep neural networks. I don't know if you ever saw a human robot working and say, but it's working really robotic. This is trying to combine making sure that the robot is not falling through classical techniques, but getting a bit of style, imitating a human that got the right information. So this is how we run the simulation. So, and this will install the software and start all the required software. If the system is not in a dirty state because I tested something before, and probably I guess it is because it's not starting. It's quite let's say new, this example. So we still didn't implement a pixi task clean a pixi task to clean up the system. So let me check if there is something going on the system. But you know, is the nice thing of doing live demos simulation. And by the way, this is a classical problem when you have multiple. Okay, you know, it worked. So this is launching Gazebo. Unfortunately, the old one. We are migrating to a new one. I hope nobody from Open Robotics simulation team is here now, because otherwise they will late me. Because this Gazebo is going to be end of life in January. Don't use it. This is just because this paper was developed 2 years ago. You know, it takes time to publish. And this is working. If you notice it, is working really slow. Actually, you didn't even see the robot take a step. Actually, I need to tell him to start doing a step, but it's really slow. Why it is really slow? Because all the complex working algorithm, at some point, to achieve really real-time performance, it needs HSL. That is a linear solver that is written in Fortran that is not redistributable. This is clearly, for reproducibility, is a big concern, because how can you reproduce something that is not redistributable? Okay, you can see it's moving really slow, really slow. We try to simplify these. So let's close this, because really is an agony to see it so slow. Yes. Can close everything. You see, this is documented. So you say, this is really, really slow. But if you should be able to get this non-redistributable solver. So you ask the user to get the solver itself, because this is something that a UK institution make available for free for academic users. For commercial users, you need to download it. But for academic users, you just need to get the source code from them, and you are not allowed to redistribute it. What's the idea? Well, the idea that we use a different environment that will use this. Okay. I'll do that. Still, we need to do a pixi cleanup task. I just the time. Okay, perfect. So if I try to run the simulation in this environment that will use the proprietary solver, what will happen is that, again, the environment will be created, and what will happen is that it's compiling the software, the C++ software of the repo, but at some point it will try to compile this non-redistributable solver, and the pixi will tell me that I need somehow to provide this source archive. Okay, takes a bit, you know, CMake, it's actually something. There are some aspects that are not really implemented. There's not super efficient. But what I want to stress out here is that if okay, perfect, you reach at this point the install CoinSL the CoinSL project, and the tarball is not available. The archive that you need to get from from the institution that makes it available and provide it available. So it gives you a nice example. Okay, please follow these steps and then put this archive there. Fortunately, I already have the archive. I don't need to write get the license, because that, even if it's free, it will take 2 days, not really compatible with the show and tell. And I just need to remember, okay, where I got it. Okay, it's here. Okay. It's not here anymore. So okay. If we are lucky. Okay, not important. I should have placed it somewhere, but something that what I want to stress is that what is happening here is, if you have the redistributable archive, you just put it in this folder, and Pixi automatically, you see there is this install CoinSL, a script to put a bit of logic, but if this available and the script is successful, it's just run through Mason the install and make the solver available, and then launches all the rest of the simulation with the or speed it up, and so it is much faster. So sorry for a bit of this, but this is really fresh. Sorry if it's not. I simply forgot to download this archive before, but if you try, unfortunately, again, this is something that you can do if you're in academic institution. Otherwise, you need to buy the solver, and it's pretty expensive. But I wanted to stress out that Pixi permits you to make it reproducible. Actually, permits make it easy to make it reproducible, even in really strange cases. MATLAB dependencies, Fortran solver not redistributable. Clearly, it's become a bit more less natural, less easy, but you still are able to do that. And I think it's really important, because then in practice, every paper always have something that is not always, let's say, perfect. Okay, so that's it for me. I don't know if you have any question. I think I filled all the time.
Yeah, amazing. Great, great presentation. Love to see these different edge cases and use cases of Pixi. I didn't even think about the whole use of downloading extra things and then building it inside of it. So that's really cool. I would also like to add to that your presentation was super clear, because this is how I experienced my research time as well. So comes back to
Yes.
to that really well.
Something that I had,
Sorry,
I wanted to add that many of those workflows of installing probably will be much simplified with Pixi build. So we are looking forward to that.
Yes, I think you're right. We're working hard on that. I don't have any specific questions. Anyone else has some questions?
I do have one, but first, thanks a lot for this amazing talk, Silvio. Like, you gave a lot of actually really complicated, you called them weird examples, which I personally like a lot, seeing Pixi being used for these kind of things. One thing that I found particularly curious is MATLAB, because in theory, MATLAB would work just as well with conda as does Python and R, but you don't really see it around, right? Like, would you say that is a technological reason, or is it like a culture thing? And if it's technological, like, what would be what are the biggest pain points with using Pixi or conda with MATLAB?
I think most of it is technological. Sorry, cultural. Yeah, that's contrary. No, that is multicultural, because most people using MATLAB are just used to, I don't know, download. MATLAB has its own way to publish their library. Most of them are commercial, and for people developing open source library, typically they have one-line MATLAB script that just download the dependency and put it in a folder, but that then it's tricky to make it reproducible or composable. Like if you have 10 dependencies, what you have is one skip for each, and if one of the dependencies have a transitive dependency, that is something for which you need a package manager in the end. But mostly of it, I think, is just cultural. People are not used to it, and they don't think about using it. From the technological point of view, it's quite simple. Like also building new packages in GitHub Action now is really easy because MATLAB provides for support for having their library in GitHub Action. So you just build it as any Python package. How do you make sure that MATLAB is finding the MATLAB libraries that you install in conda? You just set MATLAB path, like Python path. So from the technological point of view, I think it's relatively simple. MATLAB has a really good ABI binary compatibility. So we build one version of the library of the max file for an older version of MATLAB, and it works for I don't know. I never experienced any kind of ABI incompatibility. So that from the technological point of view is really nice. Sometimes there are some problem because MATLAB vendor some of their own libraries. So they vendor a really old version of STL2 that then conflicts with the version of STL2 in conda, and that is a bit of annoying, but there are solutions for that.
Nice, thanks.
Any other questions for Silvio? If that is not the case, then I would like to really thank you, Silvio. This presentation is also online on YouTube, so you can watch it later or rewatch some cool parts of it. And I would like to add that we just started a robotics channel in our Discord, so if there's any specific questions around robotics, I think it's good to start putting them there so the people that are coming from the robotics side can get more of a single channel to find information in, which would be really helpful. And then I want to thank everyone for joining and hopefully see you next time. Thanks again, Silvio, and hopefully
Thank you.
talk to you later.
Thank you very much.
It was great.
Bye-bye.
Thanks, Silvio.
Thanks. So if you like, I can also give you the PDF of the presentation.